posts that Avishai wrote?
I did not see them. I looked.
I sent them on our Slack.
Oh, they're on
No,
Discord.
not Slack, the Discord. It's called the marshmallow effect. If you scroll up a little bit, the marshmallow effect, and don't paint the roses. If you want to take a brief look, or we can just talk. So basically, the topic of a conversation are those two
Oh,
posts,
yeah. I
and
see it.
also a sort of a short argument I had with Avishai about uh, uh, let's call them binary protocols versus textual protocols or text-based protocols. Which one are better and when?
All right.
I think you were also slightly on that, AJ.
All right. Yeah, I've got these open. I might just skim them real fast while we go. I didn't see them because they came in about the same time that the post on Blue Sky came in, and so I was more focused on that than the other.
Blue Sky. There's someone on that network?
I am.
That's another thing for another day. But
it's kind
yeah.
of shocking. It's kind of shocking that you're now choosing your social network based on your political orientation.
I think I find it funny, to be honest. I think, we're in this space. I know we're live. I don't care. We're in this space where we're talking to technology people, right? And some of them are going to be on Twitter or X, and some of them are going to be on Blue Sky. So why not be in both places and help them all out?
I have to say that I have a big problem with X right now, which is the fact that I have something like 8,000 followers, yet most of my posts don't get more than 250 views, which kind of goes to show that the number of followers you have has kind of become meaningless.
Yeah.
With their algorithms. And right now I'm getting more engagements on Blue Sky than I am on X, even though I only have like 500 or so followers on Blue Sky and 8,000 followers on X.
Okay, I'm
Yeah.
curious. I should check it out.
I don't doubt that for a few reasons. I mean, like most of your followers you get in the early days, they hear what you have to say, they know who you are, and they aren't actively following or engaging. So you have this follower count that's really high, but an engagement count that's really low.
Yeah, but it's not just engagement, it's views, which means very few people are actually exposed to my content.
Right, but once they continue, if they don't engage with it frequently, because everybody's following 2,000 people, how many things can you show in a timeline? 10?
Yeah.
So as more people are, have been following you, but they're not currently engaging with your content, the number of engagements is going to sink your post to the bottom of their feed, even though they're following you, because they're not engaging with you as they follow you. So if they're not clicking the heart or they're not clicking the reply, then all of those followers will fall off, because what they're going to get more of is the stuff that they did click on the heart or the reply, which I'm dealing with now, because I used to get mostly tech stuff, and the election happened and I made a few poor choices on what to click like on, and now I can't see anything else.
Yeah, you're giving that number out, so I just got on X to look. It's funny because I'll post, thoughts on technology or whatever, and I get some engagement, but yeah, I get somewhere between 200 and 300, maybe 400 on mine, and I've got almost 30,000 followers on X.
It also, I think, has to do with two additional things. One is whether or not you're verified. Seems that if you're not verified,
I am verified.
Okay, then maybe that doesn't really help. And the other thing is they've got two tabs on the home page, whatever you call it, view. They've got the for you and following. So I would guess that if you're on following, then you'd be exposed more to the people that you're actually following.
Mm-hmm.
But I'm assuming that most people on X are on for you, since that's the default.
Yeah.
And for you is basically just the stuff that they think, that X thinks you'll be interested in, regardless of who it is that you actually follow, because most of the stuff that I see on For You is from people that I don't follow.
Yep. So, yeah, that's true. Because I'm on For You, like the people showing up here. Yeah. What I've also seen is that most of the people who I get replies and hearts from are people that I actually have more of a personal relationship with, as opposed to just, the random follower of the shows. Now, I get some of that too, depending on what I put out there, but...
So the bottom line from my perspective is that if you stay on X, if you continue to be on X, you should probably prefer to use following rather than For You, unless you have a good reason otherwise.
Yeah, I will also say that, and I think AJ was making this point, or getting real close to it, is that since Blue Sky is new and some people are interested in being active there because it's a new thing, and they're still kind of excited about whatever it is they think that it offers that X doesn't, and I'm sure there are dozens of different things depending on what the people are, you're going to get better engagement over there. And so I imagine as things kind of settle out, unless Blue Sky keeps giving us something new to really engage people with, it's probably going to settle out to be something similar to what X is doing now for you.
Yeah, my guess is it's going to be more like Vine and less like TikTok, because everything is more like Vine and less like TikTok.
Yeah, I'm looking at getting onto TikTok as well, but I haven't.
I'm not going to go there.
You engage
you
a
have
whole
enough
different
mental health
there.
issues on your own. You don't need instruction on how to be more ill.
I hurt his feelings and he left. I'm sorry, Dan. Come back. Oh, he's gone. I'll have to post a TikTok and tell him how sorry I am.
Oh, here he comes. He's coming back. He's back.
I'm back. Yeah, I dropped for a second there. Click the X on the wrong tab.
Yeah, we said TikTok and you got so flustered that you...
Yeah, exactly. No, all I was going to say is I don't like the Chinese government and the Communist Party basically informing my opinions.
I have that concern. Again, it's just back to who can I reach?
Yeah, but we are here to talk with Avishai, and instead we're talking about TikTok and X.
Oh, fair enough. We should probably just start telling people what or what we think about stuff. All right. I'll go ahead and get us started. You are correct. All right. Here goes. Hey, welcome back to another episode of JavaScript Jabber. This week on our panel, we have Dan Shapir.
Hello from Tel Aviv, which is actually cold, even though it's probably pretty warm by your standards.
He says cold. It's below freezing here, or at least was this morning. We also have AJ O'Neill.
Yo, 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 coming at you live from the wonderful, wonderful shed.
Ooh. I'm Charles Max Wood from Top End Devs. I am jealous of your shed. We have a special guest this week, and that is Avishai Ish Shalom. I hope I got close on that. I'm sorry if I didn't.
Yeah, pretty good.
So, yeah, I've thought very deeply about putting something like that in the back of my house. But anyway, Dan, you invited Avishai here, and it seems like you know each other pretty well. So do you want to introduce him, and then he can fill in the gaps for us?
Yeah, well, I do. I've known Avishai for a while. I think we worked together at Wix a long time ago. Correct me if I'm wrong. And I've wanted to have Avishai on our show for a while now, and I'm glad that he's finally able to join us. The reason for this is that similarly to Tomer Gabel, who we had on the show a few weeks ago.
He was so good.
Yeah, yes, he was. We had him on the show a few weeks ago. So similar to him, Avishai is one of those people who, when I communicate with, often it forces me to rethink or even reconsider some of my technological assumptions and even core beliefs. Things that I hold to be obviously true suddenly don't seem so true anymore, thanks to Avishai. It doesn't happen every day, but it does happen. And I have to say that, to be honest, this isn't always a comfortable experience. We as people, as humans, we dislike having our viewpoints challenged in such ways. Even as engineers, we tend to be creatures of habit. What we what we like to do, we continue doing the same thing, and we prefer to stay the course, as it were. We prefer complacency over disruption, even when we proclaim otherwise. But I think it's really important for us to go through such experiences, because that's how we grow. And when you have such interactions, you grow, or the other party grows, or ideally you both grow as a result of such engagements. Now, I recently learned that a few of our guests that we had on the show apparently did not have a good time, and that's really unfortunate. They felt a bit put upon when we asked them questions that required them to justify technical decisions that they made. And when we presented alternatives to solutions they came up with, they felt that, like, we were kind of attacking them. Obviously, we want our guests to have a great time, and I think that most of them definitely do. And I hope, Avishai, that you will have a good time as well. We will see. But more importantly than that, we want our audience to gain actual value from the show. We want our audience to learn something that actually benefits them in their career as engineers. And sometimes that requires, asking harder questions, challenging our guests on those decisions that they made. And if it does make them feel uncomfortable, well, sorry, but not sorry, because it's really a part of what it is to be on a podcast such as ours. I guess that there are others where these things don't happen. Fine. I love a lot of other technical podcasts. We have different emphases, but this is how we do things. So, if you want to come on our show, you need to be ready to answer some tougher questions. It's just the way that we do things, and that's what I wanted to say.
Yeah, I can give an example. You brought up Tomer Gabel when he was on the show, and we had a lot of back and forth on like types, strong types, type systems, and it was funny because I was thinking about it, and then I watched a talk because I live a lot of my programming life in the Ruby world, and it was a discussion between David Heinemeier Hansen and Tobias or Toby Lutke from Shopify, and they were having that same discussion, right? And it was interesting just to see kind of the trade-offs that they were talking about. And then I wish that I could go back on that episode and say, so I think you're right about this, and not, and right. And I got better informed about maybe I'm not running into the things that bring that trade-off. And I think the kinds of questions and back and forth that you're talking about, Dan, are the things that allow us to clarify that and open it up and go, okay, these are the problems you're trying to solve, not these other ones. Or these are the, this is where the trade-offs really start to click into place. Because what I find is that it's not always black and white up and down the board. It may just be your experience leads you to make this decision where I'm just not working in a space where that matters. Or maybe I just never considered that I needed to think about it that way, and you push me to do better. So I agree with you. I think some of that, back and forth, and hey, it looks like this solves the problem better than that, and we're going to give people the tools to go, oh yes, I need that, or no, I'm not quite to the place where I need that, but I need to be thinking about it as I get there. Or maybe, hey, you're talking to another group of people that think about things in a different way than I do, and all of that is constructive.
Any thoughts, Avishai?
Well, I can tell you that when I'm using static types, like I'm enjoying myself so much, and I'm like, what idiot would use dynamic types? And then when I'm using language that
it's me.
Dynamic type, wait. So when I'm using a Clojure, it's my favorite language, I'm enjoying myself so much, and I'm like, what idiot would use static types? So it's actually like once you get your mind into a specific style of programming and it feels very natural to you, it's very easy to forget all the advantages the other style has. So
yep. Cool. Well, let's talk about marshmallows. I mean,
Wait a minute. First of all, Avishai, I said
Yeah.
that we work together at Wix. Can you tell us a little bit about yourself?
Yes, I can. So I did a lot of weird stuff, I guess. I started my career as a physicist, not really in IT. And then at some point, I discovered that I'm more interested in how fast my simulations are running, more than the actual results. So I kind of switched into IT. Initially, I went into systems. I did that for a while, and then I founded a consulting company, and I worked on a lot of different stuff, a lot of large-scale architecture and performance stuff, and some training of engineers. And at some point, I stumbled into big data. It was like the big Hadoop hype back in the day. So I spent about 2 years, getting people off Hadoop because they didn't have enough data. The whole your data fits in RAM thing. And after that, I went to work at Wix. I headed a backend team at Wix. And from Wix, I went to work for VC. That's quite a career change, I guess. So I was an engineer in residence at Aleph VC. It's one of the prominent VCs in Israel. And after that, I went to work for SealerDB, which is a high-performance Cassandra clone written in C++. Very unique and interesting thing, if you want to talk about that. And since then, I've been an independent researcher. Nowadays, I'm mostly working on performance problems and training engineers, which is my current passion. I think that now that we have the AI age, we have a very big problem because everything's too easy. So you don't actually learn how stuff works. So the funnel of becoming a senior from a junior is now gone. If you think about network engineers, for example, how did you train to be a network engineer back in the day? You had your home router, and you played with it, and you needed to, let's say, define the DHCP and the DNS and all that stuff, and NAT if you had some kind of a home router, and you learned doing that. Nowadays, you just get Google Mesh and you install it, and everything works. So there's no reason for you to fiddle with it and actually learn network. So there's no funnel for network engineers anymore. So it's a problem I'm trying to help solve.
I'm thinking about all the American TV shows where you have the father lifting up the hood of the car and showing their son or daughter how it actually works, how it runs. And I'm thinking about all the new electrical cars. That's pretty much gone.
Yeah, I had this experience with motorcycles. I had one of the last motorcycles that still had carburetors. And then the following models already had the fuel injection system.
Fuel injection, yeah.
Yeah, exactly. And you can't tune it, you can't fix it. So the days of learning, yeah.
I've never heard anyone argue against fuel injection.
I've never technology, but the trade-off is that you lose the ability.
Yeah,
it's more fuel efficient. It has more performance. It's more reliable. But the downside is that you don't get to learn how motorcycles work anymore.
Right, because the fuel injection is controlled by the computer.
Yeah, exactly.
So
there's no self-maintenance.
There's no mechanical management of it.
That's interesting because I just got a motorcycle and I'm actually glad that I got one that, I got an old one, so it was cheap, but it was just new enough that it was fuel injected, and which motorcycles got fuel injected much later than cars did. I mean, a lot of four-wheelers I think are still carbureted, but yeah, I kind of felt like I dodged the bullet. I still feel like I'm learning about it, but I didn't have that sense of understanding the carburetor is key to understanding the maintenance of the motorcycle. So that's I'm really interested that you said that. I have to sit on that for a minute. I wonder what you know that I don't know that makes you feel that way. Obviously something, but
so I'll give you an example. You live in a colder climate, right? So you need to heat up your motorcycle for a little while before you start riding it. And the reason for that is because of the carburetor, and because you actually need heat for the fuel to spray in, to the mixture, so that you actually get it into the engine and it blows up. Whereas with injection system, you don't need to do that. The computer takes care of it. So the whole even this bit of pausing for a second, thinking, okay, I need to warm up my car because, colder climate, fuel mixture, all that stuff, that's gone. You're not even aware of it anymore.
So mine is fuel injected. It's just new enough to be fuel injected, but it does definitely behave differently. Like I can tell, I do get a sense of it. But yeah, the four wheeler, I actually have to tune the carburetor of the four wheeler so it'll start in the winter and not flood in the summer.
I'm still thinking about the fact that you defined yourself as a researcher, and I'm curious what that means and how that translates to real life.
So a lot of the stuff that I do right now is, first of all, a lot of reading, but also a lot of observing and experimenting. Some of it is like on how systems work, and some of it is into models. And I'm saying models specifically because it relates to how people understand systems. You don't actually understand a system because you don't actually get to directly experience a system, and you cannot perceive a system. What you perceive is a model of the system that you build inside of your head. And there are some common models that we all know, and they play a very important part in how we pass the world around us. So understanding those models or inventing new models and making them approachable to people is a very important part of teaching and also debugging and architecture and all that stuff that we do. So the research part, some of it is just going to the field and seeing what is comprehensible to people and how people pass the world that they see and how they look at the world that they see, because you view the system through dashboards and graphs and metrics, and of course all the tools that you have. And some of it is learning psychology and learning neurology, how people think about stuff, how the brain works, all the cognitive biases that go into play. And some of it is actually researching the tech stack, because that also informs and kind of conditions the way that we experience things.
And you're able to make a living doing that. Cool.
Not yet. So, I'm doing consulting, mostly on performance stuff. I am giving some workshops, which is starting to get more and more like a bigger and bigger part of the work that I do. So at some point, I guess it will become the main thing that I do. Hopefully, I can make a living just doing that, but we'll see.
I just wanted to also add that, when you were speaking about the importance of models, it kind of also directly translates to the importance of naming things and naming things properly.
Yeah, because it's not just a name, it's the name and everything, all the associations that it carries with it.
I totally agree. So I actually brought you here because of I don't know if going back to my kind of little speech at the beginning, because of this argument we had online about binary protocols versus textual protocols. But while preparing, I also read or reread some of the articles that you posted on your excellent website. And there were the latest two posts there kind of caught my eye. One of them is titled Don't Paint the Roses, and the other is titled The Marshmallow Effect. And I definitely want to talk about these as well. So I'll leave it up to you which one of those three you want to start with.
I'm cool with all of them, but let's talk about text and binary protocols for a second, because I
Okay,
think
for sure.
it's also like it ties very nicely into the other topics. So actually, one of the points that I want to make is that there is no such thing as a text protocol. It's all
Oh,
binary.
you kind of stole the one of what I wanted to say. I basically
Yeah.
wanted to say that if you go down low enough in the stack, everything is binary. It's at the end of the day, it's bits over the wire. So obviously, it's binary. And you encrypt things, you compress things. So obviously that turns them into binary data. But I was more thinking about the applicative layer. So I was making the argument that at the applicative layer, in a lot of cases, not always, but in a lot of cases, there are benefits to text-based protocols. For example, protocols that send JSON or XML or, God forbid, or or HTTP over the wire. And per my understanding, you were making the argument that in most cases, a binary protocol is what you prefer.
So that's part of it. But I think that the problem with this discussion is that it's about the serialization and the protocol itself, and it ignores the larger context of how we write software. When we have a certain protocol, and I'll give you an example of what I mean. So JSON, for example, doesn't actually specify what the size of an integer is, okay, or what the actual precision of a float is. And they kind of fixed it in the following RFCs, but not all implementations, of course, adhere to it. But the thing about this is that if you compare it to a binary protocol, a proper binary protocol, it takes much more like bytes, much more verbose in how it encodes things. So a specific number, for example, basically you have 1 byte per digit. So a very large number actually takes a lot of space, which means it has a lot of effects, but it means that when you're writing software, you would not use the same precision because of this. So the protocol actually affects how you write the code. And we have a lot of code that is written under assuming that you're going to use a certain protocol, and because of it, it's written differently. You're not actually using the same precision, you're not actually using the same data types, you're not actually writing the same software that you would otherwise. So even if the efficiency of binary protocols would be the same, and it's not, you would still prefer to have them because it allows you to write better software. And that's an angle that is not often discussed when you're talking about protocols. And just to clarify this example more, think about what happens if you want to do a denial of service attack against some server that accepts JSON or XML. You actually have to read the entire JSON before you understand that the message is done. So you have to have very large buffers, just in case someone actually decides to send like 8 megabytes of JSON. And if I send a very large and very deep JSON to you, I can very easily do like denial of service attack against the parser. Whereas in binary protocol, most of them have very strict schemas, which allow them to detect phone messages very, very easily and very early. They don't actually need to have the entire buffer. Most of them can also stream. So it makes the web servers much more efficient, much cheaper, but also immune to denial of service attacks. And this you can actually see this effect in all of the text-based protocols. So even if the protocols, they had the same payload size and the network was the same and everything else was the same, just because we can write better software, I would prefer to have binary protocols.
So here's the thing. First of all, I can get into the technicalities of some of the downsides that you mentioned, but before that, I want to explain like what caused me to say that in many cases I prefer textual protocols. But first, before that, even I want to say that obviously there are scenarios where textual protocols are totally not appropriate. So, for example, nobody would send a video stream as a textual protocol, or even images over the wire. It's probably a bad idea to send them as textual protocol.
But we do.
And I let you respond in a second, AJ. I just wanted to say that the two reasons that I wanted to say as positives for textual protocol before we get into the possibilities of some of the negatives that you mentioned is one, that it's easily humanly readable, which is significant benefit for me when I have to work with protocols. Second is the fact that in many cases I don't really care. I care that something is a number rather than exactly how many bits it takes to represent it and the exact format. And finally, is the fact that you can mix textual protocols and binary protocols together, which can get you the benefit of both worlds. And now to you, AJ.
So there's somewhat of a snuck premise in what you've said, which is that
me or Avishai?
Avishai, sorry,
okay.
Avishai. There's somewhat of a snuck premise in that you're saying if people are using text protocols, they're less efficient and they're more subject to these issues because of the text protocol itself. When I'm going to argue that because of my own experience, and I imagine you've seen this too, if you gave someone a binary protocol and it were to become popular, the binary protocol would have all of the same problems because the issue with the denial of service, not bounds checking, not having byte limits or rate limits, those are engineering issues. They're not protocol issues. They're not the fault of the data format. Likewise, what goes over the network is a bit different depending on the size of message, but we're talking about communication, not binary files. We're not talking about videos. We're talking about communication. Normally, those messages are going to fit into a TCP packet. And if they're not going to fit into a TCP packet, taking away 10 to 20% of the brackets and braces and replacing that with little size headers is not actually going to be what makes the difference in the long run of when we're exchanging messages back and forth. How do we fit them into a TCP packet? We have to, significant, like if a person's typing a paragraph, they're just typing a paragraph, that's going to fit. If it's, so there's these other things. So I don't think that I will agree with you. There's a lot of benefits to binary protocols, but I think the examples you gave are a we
I have to agree with you, by the way.
Avishai,
Yeah.
before you respond to that, I think it might, and we will definitely let you respond. I thought it might be worthwhile to provide specific examples of what we mean by textual protocol and binary protocols, because we're kind of being, talking in theory. So it might be worthwhile to translate it into actual practice. So can we give an example of a binary protocol, and can we give an example of textual protocol, and maybe if we can give an example of a mix?
So a textual protocol, for example, would be JSON. JSON is a serialization format that basically JavaScript notation, object notation. It's based on JavaScript. It's all value JavaScript. And it encodes data, strings and arrays and dictionaries and numbers as ASCII or UTF-8 characters. Whereas a binary protocol would be something like a protobuf, which encodes similar data, in this case with some schema, as bytes. So a number, for example, would be just a byte representation, which also means that numbers are represented in much more efficient way. The number 1, for example, would take just 1 byte, but also 18 and 25 would be 1 byte. Whereas in JavaScript, in JSON, the number 26 is 2 bytes because it has 2 characters. So it's actually like the text representation of a number. But AJ, I agree with you, by the way. I think that the framing this discussion as textual protocols versus binary protocols is wrong, because as Dan said, it's all binary over the wire. Really, the question is, the discussion should be specialized protocols versus general purpose protocols. And we know, it's also mathematically proven, that general purpose protocols or general purpose things are less efficient across the board, whereas specialized things are obviously more efficient in a specific use case, but maybe less efficient in other use cases. And this is why I don't like this framing of the discussion as text versus everything else. It's text was selected because it's like a universal representation. It makes very few assumptions about what goes over the protocol. And it's based on some premise which we inherited, which is that we are transmitting textual documents. And this specific assumption was more or less universal, because when it was invented in the 70s, this is basically what we sent over the network. We sent textual documents of sorts. We didn't send images or videos back then.
And if I can interrupt you for a second, I was
Yes.
about to give two more or a few more examples of such protocols. Exactly an example of a textual protocol is and it's exactly the scenario of a document over the wire, is sending the HTML document over HTTP. The HTTP headers are textual, and the HTTP body, which is the HTML document, is also textual. On the other hand, if you're sending an image over HTTP, then the header remains textual, but the body becomes binary.
And this doesn't strike you as odd?
Let me tell you a story. Several years back, I was working on software for remote access. Basically, it was running a desktop or a Windows desktop or Windows application in a data center on a server or on a VM, and accessing it remotely using the browser. So basically, replicating a Windows desktop interactively inside the browser. And you want this to be really responsive, and ideally you want even to be able to support animations. And even though I'm talking about something like 15 years back, we were able to hit something like 10 fps for videos running on the server, being streamed in this way over WebSocket to the client to be redrawn by JavaScript. And we were sending commands and images. So a command might be, you know, draw an image, but it might also be draw a line or play some sound or do some various other things that Windows user interfaces do. And we mixed. So the commands were sent as small JSON packets, and the images and audio and stuff like that, they were sent as binary. And it actually made the protocol, I would almost say, beautiful, because we were literally able to directly translate those small JSON packets into JavaScript function calls with parameters. So basically, sending commands over the wire directly translated into executing JavaScript commands. Where and the binary packets were handled as opaque binary blobs. You just gave them to the blob object, and you got an image or an audio file or whatever. So I don't see any problem with that. It's basically, if we're going back to the example of HTTP, obviously the image is not something that I'm going to be sending as textual data, and it's kind of meaningless as textual data. But being able to look at the HTTP header instructions easily, without requiring special tools, from my perspective, has a lot of value.
But you don't actually look at the HTTP without special tools. You always use some special tool. So when you look at the HTTP, you use TCP dump, which is a specialized tool, and by the way, knows how to parse binary. Or you're using a browser, which knows how to parse binary, or you're using something similar like Wireshark. All of those tools actually parse binary.
I use curl.
Fair enough.
And netcat.
Netcat is the only general purpose tool that in this case. Like curl is a specialized tool. But what prevents netcat from parsing binary?
My issue with binary is that in many of those cases, it feels like premature optimization, and it leads to even more premature optimizations.
Okay,
and the fact that I really need highly specialized tools versus generally available specialized tools in order to parse it is detrimental for my experience.
So I would say that the real problem and the real discussion here is about tooling, actually. Tooling and
it's always about tooling.
Yeah, it's always about tooling. Like the entire operating system is a tool, so there's that. But let me try to reframe the conversation a little bit here. So I view protobuf, for example, as not as a binary protocol, but rather as a carrier for a family of user-defined protocols. Okay, whereas and this is really the problem that I have with text and HTML and all that stuff, is that it's a very poor system for writing user-defined protocols on top of it. Whereas protobuf is a very good system for doing that because it was designed to do exactly that. So every message, every protocol that you write on top of protobuf is specialized, but you get to define how it behaves.
Can you elaborate a little bit about what protobuf is? Because I think many of our listeners are not familiar with it.
So protobuf is it's actually three things. It's a serialization protocol. It's a network stack, not network stack, but network protocol and schemas. And this system was designed by Google. First, it was designed for internal use. Then they open sourced it, and they also open sourced the RPC layer that came with it, known as gRPC. It's a multi-platform system. And it has a lot of fancy features, but that's not really what we're talking about here. And the way that you would use protobuf is that you would write something called a protofile, which defines a schema of messages. And then the server and the client can agree on what is being sent, and they know how to pass the messages and all that stuff. And protobuf messages can be sent over like binary network protocols and HTTP and various other protocols. You can even save them to files if you wanted to. So they're kind of universal in this way. And this is the nice thing about this, that you can actually use a carrier that's more efficient or more widely supported, depending on the use case.
I'm having a real hard time with this. It seems like you're suggesting that the network is one of the great bottlenecks that we need to be concerned with, when I don't see that in my experience. I agree that gRPC could be great for server-to-server communication in internal infrastructure, but I've also seen a talk that specifically argued against it where, I mean, you can see a talk for everything, right? So that doesn't say much, but the arguments were very compelling that the development time that they saved by having everything internal and external as JSON, being able to debug any service quickly, look in the logs, that the efficiency that they gained by not worrying as much about one of their most abundant resources was well worth it. And what I have seen with gRPC is it's a level of complexity that most people can't manage. So I'm not saying that the experts that are working in the enterprise in highly tuned scenarios shouldn't be using it. They know what they're doing. They have use cases that I personally don't have. But what I have seen looks like, and this could be a misconfiguration, but it looks like a minimum of 2 megabytes of JavaScript to be able to produce a few gRPC messages. Now, obviously, you could hand tune it, and you could do that in bytes. But what I've seen is that the generated tools, like the protobuf C, generates an entire infrastructure for protobuf to basically get out that hello world message. So I am not convinced for web applications that what you're saying aligns with the experience that I have or that I know other, I'm not seeing it.
Yeah, and you're not wrong, by the way. So here's the fundamental problem, and we said that it's a tooling problem.
Yeah, sure.
So JavaScript doesn't actually support JSON. The browser does. So what if the browser supported
at this point, I'm pretty. I mean, is it not part of the ECMAScript standard? I thought it was adopted. Am I mistaken?
No, it's V8. Okay.
No, what Avishai I think is saying. Sorry, what Avishai I think is saying is that the code that parses the JSON is not written in JavaScript. It's written in Rust or C++ or something. Whether it's part of V8 or Blink is kind of irrelevant to the web developer.
But the thing is this. So first of all, to mention the HTTP thing, I find it very odd that the headers, which are the only thing that should be very, very efficient and is completely independent of the actual payload, and whether the payload is text or binary, is text. And this is actually a very big problem that Google and the rest of the people working on HTTP3 encountered. Actually, they encountered it in HTTP2 when they tried to introduce binary headers, because of all the reasons that I mentioned, because it's more efficient, because it protects the server and client implementations against denial of service attacks and all that stuff. So actually, binary headers is something that everybody wants, but for historical reasons, we don't have. And if we designed HTTP today, we would actually do the reverse. We would have binary headers, and everything else could be text or binary. The reason that we have it in reverse is because of basically the history of computing systems and the internet. And going back to your point about gRPC versus JSON, yes, JSON is universal for historical reasons, and all the browsers support it. And this makes it the path of least resistance. So you're not incorrect in saying that protobuf currently is harder, and it's true it's harder, but it's harder because it's not universal in the sense that not all the tooling supports it natively.
Well, and this is yes, yeah, because I'm not just saying it's harder.
I also want to mention that everybody actually writes schemas, even for JSON. They don't do it explicitly, but the code actually has a schema for what the message is. And
agreed.
So it's not that you get around this complexity of writing schemas and describing the messages when you're doing JSON.
So to the first point, I'm not saying it's harder. I'm saying that it is in fact less efficient in one of the key areas that matters. I agree with you. Can we get a binary protocol built into the browser? Can we have JSON.stringify, JSON.parse? Can we get in the browser protobuf.parse? Sure, that would be cool.
We can send binary data off of WebSockets. WebRTC is a binary protocol. You can send data in it. So we kind of do. We are restricted in what we can send and the carrier, but we, to an extent, we already do.
I mean the machinery. There's a lot of machinery to produce binary.
I do want to say something about JSON and the parsing problem. Now, obviously, it's not a solution to denial of service, even though you can, build such solutions. But if you're looking at it from a straight-on protocol, what somehow eludes a lot of people is that instead of sending a huge JSON that needs to be parsed in its entirety before anything can be done with it, it's usually very straightforward to send much smaller JSON packets or parts, and then parse each one of them individually. So,
JSON-L does this, and that's a pretty decent solution.
It might,
as long as everybody on the system is well behaved.
Yes, of course.
So, okay, the one question I had earlier, CBOR and ASN1 are binary protocols that are generic protocols. I would think that in every way they suffer from the same problems as JSON. So protobuf is different. Protobuf is pack structs. So would you also say that CBOR is, pretty much just as bad as JSON, or would you put CBOR in the category of protobuf?
So I would argue that every universal general purpose protocol suffers from similar problems. It's not really about text or binary. It's more about restricting the use cases, which is where schemas tie in. And this is why I like protobuf and similar systems, because they allow you to define, the special cases, and make up your own rules about what they mean and how to use them and how to validate them. And really, this is like a big issue in computer systems in general, because it's not really about serialization. It's about systems in general. You actually see this problem in many other cases. And going back to the point that you made earlier, this is also a problem of deploying stuff in large scale, because every time we deploy a protocol, if it's successful, it becomes legacy. And legacy, it's a very notorious thing, but actually it means that you had something that worked very well. And once something works very well and becomes, widely used, now you have a problem because it's a network system, and to replace it, everybody has to replace it. Which is why it takes such a long time to deploy replacements for HTTP 1.1 or TCP or IPv4 and everything else. It's all basically the same problem. It's something that was widely successful. Now it kind of hit the limits of what it can do, and we actually suffer greatly from the limits of the current system. You can see this with IPv4, for example, but also with HTTP. There are many reasons why we want to replace HTTP. But rolling out a new version or something to replace it, it's actually a very big problem, which goes into backwards compatibility and actually having everybody install tooling, to make it universal before they can actually use it, and then start sending out the new protocol and starting to use it. So really, that's the problem. It's not that I don't think anybody argues that JSON is somehow good or like the most optimized system or the best system or anything like that. I think everybody pretty much, okay, except AJ maybe, but I think most people would agree that we can have better systems. It's just a problem of how to roll it out.
It kind of reminds me, if I recall a talk by Alan Kay, whom I admire. He gave this talk something like 20-something years ago when the web was starting to explode. And turns out that the web was really rubbing him the wrong way for a lot of the reasons that you were mentioning, Avishai. And he showed a system built, surprise, surprise, on Smalltalk that was sending messages and agents across the wire. And he replicated various web apps, whatever web apps we had some 20 years ago, with his system. And he did an interesting comparison. He was measuring the temperature of the computer running a web-based solution versus his solution, showing that his solution was running colder, much more green, much more environmentally friendly. And his system was amazing. But looking at it, there was basically no chance, because nobody was going to rip out the web and replace it with a custom solution built on Smalltalk, regardless of how amazing LNK is and how great the technologies that he comes up with are.
Yeah, because when you have a successful system, you need to have a very large advantage or very large limitation in the current system to actually pay the very steep price of replacing the entire system. And it makes sense. This is why we have legacy. It's not a bad thing. But there are many, there are already a lot of reasons, a lot of it's becoming more and more obvious that the current stack is hitting the limits, and we need to start replacing it. You see this with IPv4 because we basically ran out of address space. So we have no choice at this point. We have to replace it. It just takes a very long time. You see this with HTTP 1.1, though a lot of problems with it. So now we have HTTP 2 and HTTP 3, and we're rolling it out as we go. And HTTP 3 is based on UDP, not TCP, again, because of the limits of TCP. And now we are starting to see a movement to get rid of TCP in data centers, to replace it with UDP-based protocols.
I don't know if I'd call it the limits of TCP, rather various the implementation decisions that made total sense in the 70s and the networks that we had back then don't make sense anymore in today's cellular networks and whatnot.
Exactly. And this is the thing. It's like whenever you make a design choice, there are no right design choices. That doesn't exist. What you have is a design choice that works and works well enough. And you know that reality is going to change. Whether or not, because computers change or technology changes or the users change their mind or whatever, it doesn't matter. It's going to change. At some point, you will have to change the system. And good protocols and good systems adapt. But there's a limit to how much you can adapt. Like at some point, the basic assumptions that you made about the system are going to be invalidated. And at that point, the system is going to start hitting limits. And you can live with it for some time, but at some point you will have to replace it. So when we build systems, back in the day, in the 70s, we didn't think about future-proofing it, and we didn't think about sunsetting it and how you replace it with the next generation. Now we're smarter. We already know it's going to happen because we had this experience of a system that became very successful, the internet, and we actually got to be old enough to see it hit the limits. So we are now aware of this problem, and we know that the next generation has to be future-proofed. But we learned it the hard way.
Is it though? We will only know when we get there.
I'm pretty sure that we will have to replace everything again in like 30, 40 years, if not sooner.
By the way, this is, I think, we could talk about this. We can keep on talking about this, but I think this is an opportune time to kind of pivot to one of the articles you wrote, because it really ties into a lot of what you're saying, which is the article with this amazing name, which is "Don't Paint the Roses," which is a reference to part in Alice in Wonderland. Can you explain where this came from and kind of how it ties into what we're talking about?
The song from the Disney movie keeps playing in my head every time we.
Yeah, it's a great scene, by the way.
Anyway.
Yeah, so there's a scene in Alice in Wonderland, the Disney version from I think the 40s, right, or the 50s.
Yeah,
it was, by the way, hand painted. They actually painted all the frames by hand. And in the scene, you see the card soldiers, painting the rose bushes. They're painting them red because they accidentally planted the white roses, and the queen wants them to be red, so they just paint all the roses. And the problem with this is that at some point the queen comes, and she discovers that the rose bushes were painted, and she goes off with their heads, and all the cards lose their heads, which is very unfortunate for them. And
would never happen in a modern Disney movie.
That's true. So the thing is that we actually have a lot of painted rose bushes around us in reality. It's like something that we try to force into a form, even though the core of it, like the essence of it, is very different. And this is a lot to do with the industrial mindset, of the designer mindset, versus the organic mindset or the agriculture mindset. If you are trying to grow something that is organic, you can't actually control what it will grow into. You can, kind of try to direct it.
You can influence it.
You can influence it. You can direct it. You have, like, for example, bonsai is a very good example where you trim the roots to make the tree to make it in a certain shape, a certain size. So you can constrain it somewhat and direct the growth, but you can't actually change the essence of it. A bonsai tree will always look like a tree, no matter what you do to it. And the industrial mindset is a designer mindset, where you design something and you can actually force it to be that thing. And if it doesn't work that way, you can just destroy it and start over. So the problem we have in modern society is that we are an industrial society. And when we get to organic situations, we try to hammer them into a certain form, even though they're organic. And a very good example of this is organization building. Organizations are organic. You can't just decide that they're going to be in a certain way. But if you've been in corporate and you've lived through one of those organizational restructuring programs, you know what I'm talking about.
And it kind of has to do with what we were talking about before, about legacy systems and legacy protocols, where certainly you can say that a lot of the web has evolved more than it was designed. I think there's an excellent quote that I love in the HTTP spec, which basically says, we recognize that a lot of what is written here is kind of doesn't make sense and is even nonsensical, but that's because it evolved more than it was designed, and a lot of discrete teams were working on it and working without proper synchronization and stuff like that. So it kind of grew organically rather than being designed, certainly not top down.
A lot of the RFCs actually describe de facto protocols, which were later codified in RFCs, rather than having them, designing the protocols, documenting them in RFCs, and then implementing them. It was actually backwards.
Well, if you think about what RFC stands for, it's a request for, what is it?
Comment.
For comment. It's basically, it's not here's the spec. It's basically, I've got an idea. What do you think about it? And this request becomes codified as the actual specification.
Yeah. So it turns out that basically the web is a network of consensus. It's not so much a design network as it is an organic network that evolved, and we somehow got to a consensus about how it should work. A few years back, you had an incident where Cloudflare actually did something according to the RFC, according to the spec, but everybody else was using it differently. And this created basically an outage in Cloudflare services. And after they discovered it, they fixed it in the sense that they now conform to everybody else, which means that they violate the spec. So this is basically how the internet works. It works by consensus. It doesn't work by specification.
Anyone who's ever wondered why user agents look the way that they do?
Mm-hmm.
I remember when Microsoft released a new version of what was it? A certain version of what's their browser's name? Edge, and they broke Office 365 on Edge because they actually used the proper user agent, but that confused their detection protocol. So they had to put in a wrong user agent yet again, just in order to get things to work right.
The wheel of time keeps coming around and around.
But how do you deal with it? I mean, at the end of the day, we are very often forced to paint the roses because we need to deliver something on time within budget, and we don't have the time to grow a new solution and make it conform to whatever we already have.
So it's a mindset, actually. First of all, it's a conversation you want to have with the product manager and the business people, because it's optimizing for the long range, really. So even if you are forced to paint the rose bushes, you want to have some kind of an escape hatch. You want to be prepared to the eventuality where someone will find out this is actually painted rose bush. Because once someone discovers this, there will be consequences, and they will not be nice. It can be off with your head at some point. So if you adopt this mindset of organic growth, and you understand that as a designer, you're actually looking for experimentation, you're looking for future-proofing, you're looking for escape hatches, you're looking for minimalistic design. So a good design is one that doesn't make decisions that it doesn't have to. Because
Can you give concrete examples going either way?
For what?
Can you give concrete examples of either where painting the roses ended in disaster, or conversely was done successfully?
Yeah, so I can give actually a lot of examples of this. So, okay, let me tell you a story. Actually, if we want to go into that specific route. So, you know how we could talk about DevOps, for example. DevOps is a very good example. DevOps is a classic painted rose bush, because it started out as something organic. We had this movement that said, look, we have this problem between operations and developers that don't understand each other. There's like a structural problem in organizations. There's a structural problem in the software stack, where we have parts that don't connect to each other. And then we started trying to solve this problem. And then someone says, okay, you know what? Let's invent a new profession. We can call it DevOps. Let's invent DevOps tooling. Let's invent the DevOps team, the DevOps engineer, blah, blah, blah. And now we have a painted rose bush because we try to design a solution instead of growing one organically. And it gotten so bad that now people talk about DevOps, not interacting with ops or devs. So we have the DevOps square problem, you can call it. And you have tools that are trying to solve the problem where DevOps tools don't communicate well with dev tools or ops tools, which is completely ridiculous.
It's like it's like it was a buzzword that was created to sell AWS certificates, and you end up with all these people who create these layers of infrastructure that don't help the developers. The developers now have to wait, 15 minutes for their deploys to get through. Yeah. Oh, this is, I'll shut up now because this is one of my.
But Avishai's point, it was originally this movement to bridge the gap between infrastructure and code and make it manageable so that you could communicate about this stuff, and the way you communicated about the stuff and the way you set up your people and your processes. And that's what it got co-opted into, right? That's where they painted
sorry. I think the Phoenix Project still used it in the sense in which it was intended. The book, it's called the Phoenix Project is the name of the book, I think. That one talks about DevOps in the actual terms of what DevOps is supposed to be, like partnering with the development team and the operation team to understand both sides and provide tools that facilitate quicker and more efficient. Yeah.
Agile development had the same thing happen to it.
Another very good example.
Another interesting example I'm seeing and running into is the whole concept of shift left in development, where you say instead of having dedicated QA and automation teams, we let the developers do the automation and be responsible for the testing, which is great on the one hand, but on the other hand results in a situation where nobody owns or is responsible for the automations. And then when something breaks, nobody knows how to fix it.
And it's also very weird because, if you have a process and you shift everything left, you still end up with something in the right. You shift all the dominoes left, you still have a series of dominoes. Something's going to be on the other side.
Yeah. Before we're done, I really want to touch on the other posts as well. We're starting to run towards the end, but I'd really like to spend a few words on that. And that's another post with a great name, and it's called The Marshmallow Effect.
Oh, yeah. So the marshmallow effect basically is stuff that has the original name, but doesn't actually have any of the original ingredients. So most people don't know, but marshmallow was originally made from a marshmallow plant, marshmallow root. And obviously, nowadays marshmallow is made from corn syrup and sugar, basically. And it doesn't actually have the taste, gelatin. And it doesn't actually have the taste of actual marshmallows. Some places in Europe you can still get the original stuff. It's very hard, but you can still get it. But there's in the food industry, it's actually very common. A lot of the stuff the industrial stuff we eat today, still has the same names as the originals from 100 years ago, but it's not the same thing. It doesn't even taste the same.
I remember
most people don't know because they never ate it.
I remember growing up in the what was it, in the 80s, and in the States there was this lemonade called old-fashioned country lemonade or something like that, which had 0 lemons in it. And I remember how shocked I was by that.
I thought you were going to say that you used to drink cocaine in your Coca-Cola.
I didn't get to experience Wonder Bread.
Wonder Bread. It's another good one. In Israel, we have something called sahlab, which is like a Turkish drink, which was made from sahlab plant, but obviously now it's not. And I still remember the original Sachlab, but people who grow up now, they never actually tasted the real Sachlab. They think that what they're drinking now is Sachlab. It's not. But you also see this in technology, and I think the cloud is a very good example. People talk about like disks. EBS is not a disk.
It's a file.
It looks like, it looks like a disk. It has some fake blocks and stuff, but it's not actually a disk. It's not magnetic or SSD or anything like it. It's just a name that AWS puts on to tell you that this has certain IOPS and certain speed and build in a certain way.
But that's kind of intentional with virtualization. The whole concept of virtualization, virtual memory, going back to virtual memory, is the fact that virtual memory, it's not memory, it's files on a disk, but it's one thing that's intentionally created to look like another for various reasons.
So it's backwards compatibility, but that creates a lot of interesting problems because first of all, it impacts how people think about the system. So I'll give you an example. People often debate whether they should use S3 or EBS or EFS, which is like NFS. And then they're like, oh, but disks are, have these features or they have this speed or whatever. And it's all wrong because actually S3 and EBS are, they're actually like the same machines doing the storage. EFS is basically like the same as EBS, except the protocol that you use to communicate with it. And so the real question is not, if it's like disks or something else. It's like how many IOPS are you getting, and do you like this protocol that you're using to talk to this storage server? That's what you should be, talking about, really. But conversation people have because they don't understand that this is actually all the same storage, just presented in a different way. And you have the similar problem with VPC because it's again backwards compatibility, which you don't actually need in the cloud. I had this conversation with one of my clients where they consulted me about network design. Like, okay, so how many subnets do we need to do, and do we need to put all the this application on the same subnet? And I was like, but it's not like just because you have the same subnet doesn't actually mean everything in the subnet is physically closed. It's not going to have better latency or anything like it. It's all public network, the entire zone. It's like it doesn't matter if you use like one subnet, 20 subnets. It's still going to be the same underlying structure that you have no idea about.
So if I'm understanding you correctly, what you're saying or even lamenting is the fact that we create these sorts of virtualization layers that are kind of lies, and we do that to ease transitions, let's say, between systems. But at the end, we end up lying to ourselves because we're carrying over mindset and certain assumptions of how things work when they don't actually work that way at all anymore.
Yes, and here's what gets interesting because I'm from the generation that actually used data centers. I installed data centers and I worked in data centers, and I know that stuff very well because I actually interacted with physical machines. But now you have a generation that started their careers in the cloud with virtualization. And now they're basically eating marshmallows, and they never actually tasted the real stuff.
You're making me feel old. My first full-time tech job, or not full-time, it was part-time. But when I was a student at BYU, I was working in the data center. And a server was a server. It was a machine, right? Some of those machines were like, they take up a whole freaking cabinet. And then, right, by the time I left, now we had servers we had these servers with blade servers in them, right? And so it was a box that had a bunch of computers in it, but then we had VMware installed on those, and so then a server was this virtual thing that lived on this, right? But you still knew which server your server ran on, right? And yeah, anyway, it's been really interesting. Like we're talking about the way it evolved.
And then VMware introduced vMotion, which allowed them to move those VMs between machines seemingly without downtime.
Mm-hmm.
And then we got to the cloud, to the actual cloud, where you literally have no idea where your lambdas are running.
Right.
Yeah, and also you have very interesting discussions between people about they're saying like containers are more efficient, VMs are more efficient, and it's like a very real discussion because it's all the same stuff.
Yeah.
And we've got this problem, like Docker is recreating the very problem that it was intended to solve. So, for example, the Blue Sky self-hosted installer requires that you run on Ubuntu so that it can install all the things that need to be installed to install and configure Docker, so that it can install the packages
well, that's hilarious.
in the container in a predictable way. It's like, well, why didn't you just say Blue Sky only runs on Ubuntu, or you need to install these 10 packages on your own, right? But now it's like I have to, so in my container, I have to have nesting so that I can run Debian, so that I can run the Docker, so that I can run Debian.
Yeah, so we moved from it runs on my machine to it runs on my container. But basically
well,
the same
yeah. We can't ship your machine to the client, but we ship a clone, and still nobody knows what's going like that. This is the thing I always say. So the problem with Docker is not Docker. Docker is a great technology as a technology. The problem with Docker is that it just moved the goalpost to no one understands why my machine works. We'll ship a clone of the machine, to no one understands why the Docker file works. We'll ship. Well, and then you don't even get it because it's hosted on Docker Hub. So you don't even get to see the Docker file. So you don't even know how to recreate the container at all. So we're actually worse off, because at least before you could kind of like look at the history on the machine. Now you get a container where all the history is stripped out and you don't know how it got there.
Well, they do have the layers and things like that. But what's fascinating about it is that, and it should work anywhere, but yeah, it does make assumptions about how your Docker's set up on your machine.
I don't
Plot
know if
twist. Then it's a Go binary, and it didn't need any of it anyway.
Yeah, I'm ashamed to say that I've managed to have a pretty good tech engineering career without, truly understanding the finer details of Docker.
But
it's just a Linux process group.
Yeah.
It's just a process group. It's just like forking from a process, but with more kernel level security.
Oh, that's
I want to make a shameless plug. Like about a decade ago, Nati Cohen and myself had a workshop called Rubber Docker, or Docker from scratch, where you write your own Docker clone in Python, and you basically implement Docker using Linux system calls like clone and fork, and over the file system, and the namespaces and C groups and all that stuff. So it actually gives you a pretty good idea of how Docker works under the hood. It's all open source. It's in GitHub. You can put links to it later if you want.
Yeah,
I would love it.
Cool. Nati is great. Even though he's moved over to the dark side, I think he's working at AWS now. We should probably have him on the show as well. Also, Karen, his wife, is pretty amazing as well. Anyway, I'm digressing.
Yeah, I just wanted to say about Docker. It's a very good example of like how the discussion kind of trailed off, like in the community, because we had this tool. Because really the problem is not Docker, it's not containers, it's reproducible builds.
Mm-hmm. Yep. Which, when you think about it, yeah, then you start like my brain started going to other places, right? These are the other tools that I've used to solve similar problems.
Mm-hmm.
Yeah. All right. Well, is there anything else that we want to kind of kick around? Different marshmallows to kick around, or conversations to paint red before we?
Now you really want you got me to really want to try out real marshmallows.
I know. I'm curious too now.
Yeah, it's hard to find, but if you find them, it's very interesting.
The funny thing is when you find one of the original things and then you discover you don't actually like it. I think our current modern
right.
Yeah, our current modern ketchup, for example, has nothing to do with the original ketchup.
You know the story about ketchup in Israel, right?
Yeah, yes, I do. But you can tell it's a really weird one that shows how bureaucracies work and how business interest and bureaucracies can go hand in hand.
Yeah, you tell it.
So basically in Israel, we have a local brand of ketchup. And at a certain point in time, somebody started to import Heinz ketchup. And that was starting to eat into their market share. So what they did is they changed the legislature on what can be legally termed as being ketchup in such a way that Heinz ketchup could no longer be called ketchup in Israel. So instead, it's called sweetened tomato sauce or something. And they got to keep the term ketchup for themselves. But it didn't really help them anyway because people just bought Heinz, regardless of what it was, what it said below the Heinz moniker.
Oh, that's so funny. Points for creativity, though.
Yeah, getting to the point where Heinz ketchup can't be called ketchup.
Yeah, well, I found a thread on Reddit, but yeah. Oh, all right. Well, I'm going to push us into picks. AJ, do you want to start us off with picks?
Goodness. I don't know. Sorry, I actually today don't have anything top of mind. I'm going to need a minute myself.
All right, Dan?
Okay, so I actually have a pick I'm really happy about, and it's this new TV show called The Penguin. It's about this Batman character, one of the Batman's villains, and what can I say? It's just an amazing show, and so far, by the way, Batman makes zero appearances. There's no mention of superpowers or anything like that. They do make occasional references to the latest Batman movie, but it's really subtle. Um, Colin Farrell is absolutely amazing as the Penguin. He's totally unrecognizable. The makeup, the prosthetics. I understand he even shaved his head for the role in a certain way. But his acting is it's James Gandolfini level, really. He's giving the performance of his life, I think. Highly recommended. Um, so that would be my first pick. Everybody else there, by the way, the acting is good all around, but he just stands out. I really hope they're able to maintain this quality all the way through. I'm kind of halfway through the first season. I think it's the only season so far, and I really hope it doesn't get canceled or anything like that. So that would be my first pick. The second pick is I created an account on Blue Sky. So if you for some reason have left X and are on Blue Sky, then you can follow me now there as well. I'm even part of a pack. There's a web performance pack, and I'm on there. Um, and it's very much like X, you know. It's if anything, it's kind of like what X kind of used to be, in a lot of ways. The algorithm feels less intrusive, which is a plus. The weird thing to me, especially as in kind of an outsider to U.S. politics, is the interesting fact that there's kind of a political divide between those people who stayed on X versus those people who went over to Blue Sky. They're kind of saying that they went over to Blue Sky because they were sick of the politics and wanted more pure technical stuff, but the politics really still shine through. It's just a certain aspect of politics, and I'm not criticizing either ones, you know, but it's just a shame that people really have gotten to the point where they can't talk with each other to the extent that they feel that they need to be on different social networks. Um, but I'm still on both, and you can find me either place. It's kind of annoying to have to post things twice. I think there are tools that should make it easier for me, and probably need to adopt one. But right now, I'm still kind of posting at both places. And those are my picks for today.
Awesome. AJ, did you want to jump in or should I go?
Oh, I'll just come up with something. I think I mentioned before that I'd played Portal a few weekends ago and got all the way through it for the first time. And actually, most of the quotes that I remember were from Portal 2, not Portal. So that's still to come. But if you haven't played Portal and you want a game you can just sit down and play in a matter of a few hours, the Companion Cube bundle is available on Nintendo right now until December. We're not even going to release by then. Anyway, check DecoDeals.com. keep your eye on decodeals.com and find out when games you love go on sale and get them there. But Portal it's definitely worth it. If you haven't played it and you just know the references, the cake is a lie, that sort of stuff.
Yeah.
It's a little bit morbid to play with a 5-year-old. Like the first 10 levels are fine, and then all of a sudden there's blood on the wall, and my daughter's like, "Why is the blood on the wall?" That's all.
How does she recognize blood? Can't you just tell her it's ketchup?
Or tomato seasoning?
They were eating hamburgers, and
So
they were.
I don't lie to my kids, and I don't baby down explanations when
Well,
my
it's not really
3-year-old.
blood. It's red pixels.
Yeah, but okay, fair. But it's representing. It is not representing ketchup. It's representing blood.
It's white roses painted red.
Well, with my kids,
White
even
walls,
my
battered red.
3-year-old, when he asks a question, I will answer his question like an adult. And sometimes he will then ask, well, what does this word mean? Or what does that word mean? And our daughter, she asks, what does this word mean? What does that word mean? I am waiting for her to ask, where do babies come from? It's got to come soon. But that one's going to be a very, I don't know how to, that one I'm not going to say it like I would to an adult, I don't think. But
I'll tell you this story from my childhood. When I was like 7 or something years old, somebody used the word prostitute around me. So I went home and I asked my mother, "Mom, what does the word prostitute mean?" And she, having the similar mindset to yours, said it's a woman who sleeps with men for money. And I couldn't figure out for the life of me why somebody would pay someone to sleep with them, because it's so uncomfortable to have to share a bed with somebody. You don't have as much space. And yeah, I just couldn't figure it out. Anyway.
Yeah.
Well, when I was 5, I asked my dad, and my dad told me in as least graphic terms as he could, and I just thought that sounds so weird and gross. But then when I was about 13, I was like, got it.
All right. I'm going to throw in some picks. I always do a board game pick. I don't think I'm trying to remember if I picked this game last week or not. Maybe I'll just pick a different one. So not this last Saturday, but the Saturday before, I was helping teach games at the board game convention, right? So I have 5 or 6 games that we taught. I've already picked challengers on here because I picked that. I played that game at SaltCon in March, and that was one of the games we taught. And there's another version of the game called Challengers Beach Cup, which is the same rules with different cards that have different abilities. So I feel a little bit funny just picking either of those because you guys can go pick them up. And it's plenty fun. It's, the tournament war flag thing. You can go listen to the previous pick. So I'm hoping I didn't pick this last week, and if I did, I apologize. But probably one of my favorite games that we taught this time is called Gnome Hollow. You guys aren't looking at me like I picked this last week, so I'm going to go with it. So effectively, it's you're playing a game where you're placing hexagonal pieces on the board. So you push them together, and they create a path. And if the path creates a circle or a complete circuit, because a lot of them aren't circles, right? They curve at different angles, but you have to get them all to a line. You can't create anywhere it dead ends on another piece. So if you put it down, it has to continue any paths that it crosses. But you make these circuits, and then as you create the circles, what happens is you move markers on your board that's in front of you down, and you get a reward for it. Now, the 3s and the 4s, you don't get rewards for. The 5s, you get rewards. 6s, you get rewards. And the 7s, you get rewards. And 2 of the spots on the 7s, 2 of those rewards are you get to move another marker down, and then you get something else with it. The game ends when all of your markers move down, or when you run out of tiles. And then you add up your points, and whatever points you have, you win. So you get points for each marker you've moved down, right? And it's just, you get all of them down. It's worth 25 points. as you complete circles, you discover wildflowers, and you automatically get one of those wildflowers, and you get a wild token that you can use anytime on your turn. And then what some of the rewards are, you get the wildflowers that other people discovered, and those tally up. You get so many unique ones, right? And so if you however many flowers, you get your points for that. And then as you complete the circles, you get the mushrooms that are on the circles. Or there are other ways to get mushrooms, but you get those mushrooms, and then you can go to the market and sell them back, and you get points in return. And that's essentially the game. There are a few other nuances, but it is really a fun game. It takes about 45 minutes to play, and Board Game Geek weights it at, let's see, it's coming up 2.20. So casual gamers is pretty approachable. It's really just visualizing how your tiles get you the size of the circle you want, and you move gnomes around to claim circles or to get mushrooms or go to market, and that's the other piece to it. You have 2 gnomes that you can move each turn. So that's it. That's the game. It was, like I said, really fun. When I was teaching people, it'd take an hour. But honestly, with 3 or 4 people, we were still, once people knew how to play, it was like 45 minutes because the turn order is real quick. You put down 2 tiles, you collect any rewards, you move your gnome, do whatever's involved in moving the gnome, next person's turn. So anyway, so I enjoyed that. It's one that I kind of want to buy. So I'm going to go ahead and pick that. The other thing that I'm going to pick here, so I am actually on my new computer. My laptop, it was funny, we were talking about Docker, the Docker engine on the Mac. When I was running one of my clients' apps on it, it just got to the point where it just wasn't, it worked, but it was super slow. And so I determined that I needed, the laptop's 6 years old. And it just wasn't keeping up. And no matter what I did to try and clear stuff off or not run as many things, it just didn't quite hack it. So I looked around a new Mac at the level that I wanted, because I'm starting to do AI stuff, and I want it to be able to run that stuff. And then it really bogged down. The laptop did. I'm like, okay, so the machine at the level I wanted, a new Mac was going to cost me like $9,000.
So you wanted something like an M4 or something?
Yeah, something. So what I wound up doing was I looked around and I thought, okay, well, a lot of folks in the Rails community are talking about these Linux machines that they're picking up. So the laptop brand that a lot of people are going with is Framework laptops, and they run Ubuntu or whatever you want, really. And then for the desktops, they've been going with System 76. And so that's who I'm going to pick, is System 76. I got a desktop from them. It cost me about $3,000.
That's still hefty.
Yeah, but I can't remember all the specs on it, but it's a pretty serious machine. And
you got more than just 1 terabyte of storage for that $3,000, unlike on Apple.
Right. So I got the Thelio model.
What CPU does it have, by the way?
I'm looking it up right now. So it has, I can probably just pull up my order.
Probably some AMD or something.
Yeah, it does have an AMD. Let's see. I got the Thelio Mira Elite as a 24-core 14th gen Intel i9.
Ah, Intel. Cool. Interesting.
Has 128 gigs of RAM, 4 terabytes of storage. AMD Radeon RX 7900 GRE. Yeah. So I've been pretty happy running stuff on it, and you don't void the warranty if you have to repair it or add cards to it or anything.
It's not Apple.
No, it's not Apple, and it cost me about $7,000 less than it would have cost me to get a comparable Apple machine that did that had mostly similar specs.
And you're running Ubuntu on it?
I'm running Ubuntu on it.
Interesting.
And I wanted to run the Omakube setup, which is what DHH runs, but I would have had to reinstall Ubuntu, and I'm lazy and I didn't want to do that. So I'm not doing that. But I also switched my development environment back to Emacs, and I've been pretty happy doing that. So anyway, it's been super
old school.
Oh yeah, I love me some Emacs. I had the Emacs key bindings running on VS Code, so it really wasn't too much of a switch. The biggest switch is remembering to hit Control instead of Command.
And writing scripts in Lisp.
Yeah, well, so that's my third pick. So part of getting into AI, I kind of on a lark started asking ChatGPT to help me write code, right? And before, what I would do is I would ask it, hey, like when I was trying to write an audio player, right? And so I would ask it to help me. Okay, how do I, what's the web audio API for, if I click a button to have it play the audio? Because you can just put the audio tag in, tell it to show controls, and you get an audio player. But it's not a very nice audio player, right? And it doesn't have all the features that I wanted. And so, I started asking it, how do I get this? How do I get that? And then on a lark, I said, can you write me an audio player? I'm using Stimulus.js, and it wrote it for me. And then it was like, okay, I want this feature and this feature and this feature. And it added them in. And then I asked it, what features is it missing? And it told me a whole bunch of features I could ask for. And so I asked it for those. And then I copied and pasted the whole thing into my app. And wouldn't you know it, it just worked.
So, as a spoiler, we're going to have Uncle Bob as a guest on the show in the near future. Maybe we should also get Richard Stallman, if he ask him if he's willing to come on the show.
I'm open to that. I think it'd be great.
Yeah.
The other thing that I've been doing with ChatGPT is just sometimes I just need a little bit of direction here or there with stuff, and it's been great there too. So I'm going to pick ChatGPT as well. I might be a little late to the game there, but it has been this amazing tool. It's helped me with layout stuff. One thing that I'm working through right now for my client is they have a report essentially that's generated every time a new transaction's added to their ledger, and it takes forever to run. And so I've been playing with it on how do I run this report just in PostgreSQL. And so, I mean, it's been there's a lot of refining, right? It's like, okay, I need it to do this now, and I need it to this, I need it to operate in this way. And it's been pretty awesome. I mean, I've had to tweak a few things, but it's been wild. So, if it's not a tool you're using, I understand that Claude is another tool that you can use. We just recorded an episode on Ruby Rogues where we were talking about how to do a lot of this stuff. And a lot of the things that we talked about are applicable to JavaScript as well, just on how the tools work and what some of the tools are. Some of them are Ruby specific, but a lot of them really aren't. So anyway, I'm really, really happy with all that. And I am working on the AI Dev Bootcamp. That's going to be at aidevbootcamp.com. I'm reworking a ton of stuff on Top End Devs and getting that deployed. And so you'll be able to sign up as soon as I get that deployed, is essentially what we're looking at. So right around Black Friday or Cyber Monday. And I kind of have a number of people that I want in the first cohort. And so I think I'm going to offer a Black Friday deal that's going to be just considerably less than what I'm going to charge for it in the long run, just so that I know, hey, I've got about 20 people in that are going through the boot camp starting in January. So keep an eye out. If you want to, you can just email me, Chuck at topenddevs.com, and I can just tell you when it's up, or, however you want to do that. But yeah, just some way awesome stuff there. All right, Avishai, what are your picks?
I'm going to go with, I recently discovered Marimo. Marimo is like the next generation replacement for Jupyter Notebook. So it's like a kind of a interactive Python environment that is also like graphical. So you basically evaluate cells, or you can combine Markdown and graphics and Python output and stuff like that. And it's very handy to build widgets or calculators. That's most of what I build with it. I build like queuing theory calculators and like various system design things that basically you can put like the bars and inputs, and then like just runs a Python thing. So it's very easy for doing interactive stuff, especially that involves graphing and mathematics, that kind of stuff. Previously, I used VS Code and Jupyter Notebook for this, but Merimo is like, it's really cool. So check it out.
Nice. Yeah, a lot of people doing interesting stuff in AI with Jupyter Notebook. So that sounds interesting. All right, Avishai, if people want to find you on the internet, I see that your handle's on your video, but for the people who aren't getting this on video, how do they find you?
So Nukenberg on Twitter, that's Nukemberg. I'm mostly there. Also, I have a YouTube channel, which is not very active, but it does contain like a playlist of a lot of talks that I've given over the years. Or you can just Google Avishai Ish Shalom or YouTube or Google, and you can find that stuff.
Awesome. All right. Well, let's go ahead and wrap it up. Until next time, folks, Max out.
Bye.
Bye. Thank you for having me. It was fun.
Yeah. All right. Hang on for a second. I got to end the stream and then make sure we're all uploaded. So.